Okay, for the last example, we're going to find the second order partial derivatives. So thus far, we've only been looking at the first order partials. Now we're going to look at what are called second orders. So here's what I would suggest. In order to come up with the second order partials, you first need to determine the first order partials. So let's go ahead and do that. So the first partial with respect to x would be what? This would be handled the same way we did months ago. So the derivative of x to the fifth is 5x to the fourth. This is new in this section, of course. So the derivative of this with respect to just x would be what? The derivative of this component, which would be 2x. And then you keep this part the same. You're holding this as a constant. So because this is being multiplied by an x component, it's going to remain. There it is. All right, this term, the derivative of x, is just 1. And now the derivative of y, well, that's considered to be a constant. What's the derivative of a constant? 0. What's the derivative of this? Well, it is a constant. 7, it's also 0. So this is the first partial with respect to x. Let's go ahead and figure out the second partial, or excuse me, let's go ahead and now figure out the first partial with respect to y. So with respect to y, if it's just a single x term, this entire thing is considered to be a constant. So the first partial with respect to y, this is considered to be a constant, which means the derivative of this is 0. Okay, moving on to the next term. The x squared will remain because it's being multiplied through a y. All right, so we're only differentiating the y squared part, which is 2y. So we would get 2x squared y. The 2y is the derivative of y squared, and we leave x squared alone. All right, this x is considered to be a constant because we're, again, differentiating it only with respect to y. So it's 0. The derivative of y is 1. The derivative of 7 is 0. All right, so this is the first order partial with respect to y. Now, let's move on to the second order partials. Well, just like when we looked at the second derivative several months ago, we're going to be basing the second order partial derivatives off of the first order partials, just like the second derivative was based off of the first derivative. Okay, so how do we notate that? We write f sub xx. This is the second order partial with respect to x. All right, so in other words, what this really means is the first order partial is with respect to x, and now the second partial is also with respect to x. So looking at this expression, let's go through the motions. The derivative of this with respect to x would be 20x cubed. The derivative of this with respect to x would be, well, the derivative of x is 1. Everything else is held to be a constant. So this really means 1 times 2 times y squared, giving us this. All right. What about the second order with respect to y? Again, this really means you've already determined the first order with respect to y, and now you want to determine the second order with respect to y as well. So, looking at this first term, you have both an x and a y involved. You have a product of those two, which means this entire first piece will remain. It's not going to go anywhere. So what is the derivative of y? Well, the derivative of y is just 1. So you get 2x squared. Again, just think of this as like maybe the number 20, okay? If this was 20y, and you're coming up with a derivative of 20y with respect to y, the answer would just be 20, okay? So just think of this as any constant. It's going to remain. All right, the final thing we have to come up with is this one, the first partial with respect to x and the second order partial with respect to y. So to do this one, we first look at the f sub x, the first partial with respect to x. And now what we're going to do is switch gears, and based on this, we're going to come up with the derivative of the first partial, or excuse me, we're going to come up with the second partial now with respect to y. Okay, so this is now going to be considered a constant. So with respect to y, the derivative of this is 0. Okay, What about this one? Well, we have a product of both an x and a y. So the derivative of this with respect to y would be what? This stays the same. It's held to be a constant. The derivative of y squared is 2y. So I'll write this down. You get 2x times 2y, which gives us 4xy. Now, if you look at this one, the first order partial with respect to y, then the second with respect to x, you would base it off this one, the first order partial with respect to y, and now you're differentiating it secondly with respect to x, okay? The second order with respect to x. So again, you have a product of an x and a y here. Let's see what happens. You end up getting what? Well, you get 2 times the derivative of the x component, which is 2x, keeping the y, all right? Okay, so the product here is, oh, guess what? It's 4xy. So really all we needed to do is figure out one of these. Doesn't matter which one, because they will always, there's a theorem that tells us this, it was in the notes. The first order with respect to x, second order with respect to y, is always going to be equal to the first order with respect to y and the second with respect to x. Hope that helps. If you have any questions on this, please consider joining my Zoom meetings or send me an email. Hope you're staying healthy. Hang in there.